forces and vectors. So just as we looked at vectors and motion, it's going to be very similar here for vectors and forces in the fact that we can split them up into their components. So let's have a look at 100 Newton force. Again, we can imagine 100 Newton force as a vector that's 100 units in length. So let's draw our XY axis in. And if this force was acting at a 30-degree angle, we can just split this up into each of its components in the Y direction and the X direction. So in the X direction, we can do just as we did before, the length of the vector multiplied by cos of the angle that it acts at. And for the Y direction, it's the length of the vector multiplied by sine of the angle that it acts at from the positive X direction. And calculating these, 100 cos 30 is about 86.6, and 100 sine 30 is just 50. So what we can imagine here is that we have a length of 86.6 in the X direction, and then a length of 50 in the Y direction. It's the same as an overall effect of 100 newtons in a direction of 30-degree angle. And it's much more useful to split up the components in dealing with vectors in these real-world situations. So let's have a look at an example. Let's go ahead and draw in an incline. Say this incline is on a 30-degree angle, and there is a box on the incline. Let's give the weight of the box as 10 kilograms, which is roughly 100 newtons. Say we're pushing the box up the incline with a force of 200 newtons. There's some frictional resistance of 50 newtons, and there's a normal force of 87 newtons. And we want to know the overall movement of this system. So the overall movement of the system, what we have to do is analyze the vectors in each of the horizontal and vertical components. But in this situation here, instead of using our XY axis in a direction like this, we can actually turn our XY axis to be parallel with the incline. So it would make much more sense to think of our XY axis on an angle like this at 30 degrees. Which is kind of tricky to think about, but as long as we reference everything with this axis, everything will be okay. And the reason we want to do this is because this vector becomes parallel to the x-axis now, this vector becomes parallel to the x-axis, and this vector becomes parallel to the y-axis. And the only vector we'll need to split up in terms of its components is this 100 Newton vector. Whereas before we would have had to split up 3 vectors if we use this as our reference axis. So by turning the axis of reference, we're able to save ourselves a bit of work. And what we want to do is split up this vector in terms of its x and y components with reference to this axis. So we need to create 2 vectors, one parallel to this x-axis, one parallel to this y-axis, that form this vector here. And the way to do that is to just draw in 2 lines so let's draw in a line parallel to the y-axis and parallel to the x-axis. So if they were to form together, they would form a rectangle. And these are our new x and y components that define this vector here. So once we work out the lengths of these vectors, we can almost disregard this vector because these 2 vectors are the same thing as this vector here. Using a bit of clever maths, we can work out that this angle here is 30 degrees. And we can do that by imagining this line being dropped here, which makes a 90-degree angle, which makes this angle in here 60. This one vertically opposite 60. We know this one's 90, which makes this one 30. So I just couldn't fit it in there, but we're saying this angle in there is 30 degrees. Now we can get the components of the 100 Newton vector. If you can imagine this triangle where the length of this is 100 newtons and this is 30 degrees, this is the adjacent side in this triangle, which means this is 100 cos 30. So this part here is 100 cos 30, which means that this one here is 100 sine 30. It's probably easier to imagine that one as this one here being the opposite side in this triangle with that angle being the reference, but it's the same as that vector there. Now to work out what's going on in the system as a whole, we just look at the vectors in each of the axes. So with the y-axis, we've got our 87 going in the positive direction and our 100 cos 30 going in the negative direction. 100 cos 30 is about 87, so we get 0 movement in the y direction, which should hopefully make sense, otherwise the box would be either floating off the incline or moving through it. So it makes sense for there to be 0 movement in this y direction because the box will just stay on the incline. But what about in the x direction? So we've defined positive pointing up the incline. So any vector pointing up the incline will be positive. So we're going to get 200. Now we have minus 50 minus 100 sine 30. So there was 3 vectors in the x direction. So there was the 200, the 50 going against what we defined as positive, and as well as the 100 sine 30 going against what was positive. And if we calculate all this, so this was with the y direction and this is with the x direction. So if we calculate all this, we're just going to have 200 minus 50 minus 100 sine 30 is also 50, and 200 minus 50 is 100 newtons. And because that answer is positive, it acts in the direction that we defined as positive. So the overall movement of the system is a force of 100 newtons pushing this box up the incline.